Hello students, welcome to this lecture on statistics. So in this lecture we will discuss exercise 13.3. Okay, so in the first question here we have the following frequency distribution gives the monthly consumption of electricity of 68 consumers of a locality. So find the median, mean and mode of the data and compare them. Okay, so let us solve this problem. So here we have in this column monthly consumptions in units. Okay, and in this column we have number of consumers. So in first class 65 to 85 there are number of consumers 4. In this monthly consumptions 85 to 105 there are number of consumers is 5. Okay, and in this class we have number of consumers 13, and in this class we have number of consumers 20, and in this class here we have the number of consumers 14, and in this class here we have the number of consumers 8, and for this class we have the number of consumers 4. So now to find the class marks the following relation is used. So you have studied in your previous lecture, so there you have studied the formula for finding the class mark, that is class mark is equal to upper class limit plus lower class limit divided by 2. Okay, so by using this formula here we can find the class marks, and now here taking 135 as you mean A. Okay, and DI, EY are calculated according to the step deviation method as follows. Okay, so in this table here we computed the values of xi, di, ey and fi ey. Okay, so in this class here the value of xi, that is class mark is 75, di is minus 60, ey is minus 3 and fi ey is minus 12. And in this class here xi is 95, di is minus 40, ey is minus 2 and fi ey is minus 10. Okay, and for this class here xi 115, di minus 20, ey minus 1 and fi ey is minus 30. And for this class here xi is 135. Okay, and here the di is 0 and ey is also 0, since ey is basically di by 20, and here di is 0, so ey is also 0, that is 0 by 20, that is equal to 0. Okay, and then the product fi into ey, this is also equal to 0, since since ey is 0, then product fi ey is also 0. And now for this class here xi is 155, di is 20, that is xi minus 135, that is 155 minus 135, that is equal to 20, and ey, this is equal to di divided by 20, and here di is 20, so ey is equal to 20 by 20, that is equal to 1. Okay, and fi ey, this is equal to actually product of fi and ey, and here ey is 1 and fi is 14. Okay, so fi ey, this is equal to 14. And now for this class is 165 to 185, number of consumers fi is 8, xi class mark, that is actually equal to 175. Okay, and now di, this is actually equal to xi minus 135, and here xi is 175, so di is equal to 175 minus 135, that is equal to 40. Okay, so di is 40. Now ey, this is equal to di by 20, so here di is 40, so ey is equal to 40 by 20, that is equal to 2. Okay, so now fi ey, this is equal to 8 into 2, that is equal to 16. And now for this class 185 to 205, here xi is 195, di is 195 minus 135, that is actually equal to 60. Okay, so this is equal to 60, and ey, this is equal to di divided by 20, and here the value of di is 60, so ey is equal to 60 by 20, that is equal to 3. Okay, so ey is equal to 3, and now fi ey, so here fi ey is equal to 4 into 3, that is equal to 12. Now if we add the values of number of consumers, then you will get this is equal to 68. And if we add a5 ey all these values, then you will get this is equal to 7. Okay, so from this table here, summation of a5 that is equal to 68, and summation a5 ey this is equal to 7. Okay, so now here the class size h is equal to 20, and mean x bar this is equal to a plus summation a5 ey divided by summation a5 times h, and here the value of a is 135. Okay, and summation a5 ey this is equal to 7, and summation a5 this is equal to 68, and h is equal to 20. So now if we substitute these values in this formula, then you will get mean x bar this is equal to 135 plus 7 by 68 times 20. Okay, and this is equal to 135 plus 140 divided by 68. Okay, and this is equal to 137.058. Okay, so the mean x bar this is equal to 137.058. Okay, and now from the table it can be observed that the maximum class frequency is 20. Okay, so if we now observe the table, then you will get the maximum class frequency is 20, and this frequency belonging to the class interval 125 to 145. Okay, so here the model class is equal to 125 to 145. So lower limit of the model class is here 125. Okay, and class size h this is equal to 20, and frequency f1 of model class is equal to 20, and frequency f0 of class preceding the model class this is equal to 13, and frequency f2 of class succeeding the model class this is equal to you will get from this table. Okay, so this is equal to 14. Okay, so now you can use the formula for finding the model. Okay, that is actually L plus f1 minus f0 divided by 2f1 minus f0 minus f2 times h. Okay, by using that formula you can find the mod of the data. Okay, so now let us move to next problem. So in next problem here we have, if the median of the distribution given below is 28.5, then find the values of x and y. Okay, so we have given this information, okay, in two columns. In first column here we have class interval, and in second column here we have frequency. Okay, so when we have class interval 0 to 10, then we have frequencies 5. Okay, and for the class 10 to 20, frequency is x. For the class 20 to 30, frequency is 20, and for the class 30 to 40, the frequency is 15, and for the class interval 40 to 50, frequency is y, and for the class 50 to 60, the frequency is 5. Okay, so now if we take product of them, then actually total product is equal to 6 to 3. This is given to us. Okay, so the cumulative frequency for the given data is calculated as follows. So in this column here we calculated cumulative frequency. Okay, so for this class 0 to 10, frequency is 5, cumulative frequency is 5. Okay, and for the class 10 to 20, here the frequency is x, and cumulative frequency actually equal to sum of this frequency plus this frequency, that is 5 plus x. Okay, this is the cumulative frequency for this class. And now for this class 20 to 30, here frequency is 20, and here cumulative frequency is equal to 25 plus x. And for the class 30 to 40, here the frequency is 15, and cumulative frequency is equal to 40 plus x. And for this class 40 to 50, here the frequency is y, and then cumulative frequency is equal to 40 plus x plus y. Okay, and for this class 50 to 60, here the frequency is 5, and then the cumulative frequency is 45 plus x plus y. Okay, and here the total frequency is equal to 60, that is given to us in our question. So from the table now it can be observed that n is equal to 60. Okay, so n is equal to 60, and here total cumulative frequency, this is 45 plus x plus y. Okay, so now from this given information, here we get this equation 45 plus x plus y, this is equal to 60. Okay, and it implies x plus y, this is equal to 15, and naming this equation number 1. So median of the data is given as 28.5, which lies in the interval 20 to 30. Okay, so therefore the median class is basically 20 to 30 here, and here lower limit of the median class, this is equal to 20, and the cumulative frequency CF of class preceding the middle class, that is equal to 5 plus x here, and frequency f of median class is equal to 20, and class size h is equal to 10. And we know the formula for the median. Median is equal to L plus n by 2 minus CF divided by f times h. Okay, we know this formula. So now if we substitute the values of L, n, CF and f and h, then we'll get in this this is equal, this implies 28.5. This is equal to 20 plus 60 by 2 minus 5 plus x divided by 20 times 10. Okay, and now if we simplify this equation, then we will get this implies 8.5. This is equal to 25 minus x divided by 2. Okay, so from this equation, if we further simplify this equation, then we will get 17. This is equal to 25 minus x, and it implies x is equal to 8. Okay, so now from the equation number 1, so from this equation here we get the value of y. Okay, by substituting the value of x is equal to 8. So from equation 1 here we get 8 plus y, this is equal to 15, and it implies y is equal to 7. Okay, so y is equal to 7. So here we get the value of x is equal to 8 and y is equal to 7. Hence the values of x and y are 8 and 7 respectively. Okay, and now let us move to next problem. So in next problem, here we have a life insurance agent found the following data for distribution of ages of 100 policy holders. Okay, calculate the median age if policies are given only to persons having age 18 years onwards but less than 60 years. Okay, so let us solve this problem. So first of all, here we make this table. So in this column we have age in years, and in this column here we have number of policy holders. Okay, so below 20 age there are number of policy holders is 2. Okay, and below 25 there are number of policy holders is 6, and below 30 age there are number of policy holders 24. Okay, and below 35 there are number of policy holders 45, and below 40 there are number of policy holders 78, and below 45 there are number of policy holders 89, and below 50 there are number of policy holders 92. Below 55 there are number of policy holders 98, and below 60 there are number of policy holders 98. Okay, so now and below 60 there are number of policy holders 100. So here class width is not the same. Okay, so here the class width is different, so there is no requirement of adjusting the frequencies according to class intervals. Okay, so the given frequency table is of less than type represented with upper class limits. Okay, so the policies were given only to persons with age 18 years onwards but less than 60 years. So therefore class intervals with their respective cumulative frequency can be defined as below. Okay, so that is defined in this table. Okay, so age in years 18 to 20, number of policy holders Fy is 2, and cumulative frequency Cf is 2 also. Okay, and for this class number of policy holders 6 minus 2, that is 4. Then cumulative frequency is 2 plus 4, that is equal to 6. Okay, and for this class number of policy holders, if I, this is 24 minus 6, that is equal to 18, then cumulative frequency C is equal to 24. Okay. So then for this class 45, for this class 78, and so on. So total N is equal to 92 here. Sorry, from this table it can be observed that N is equal to 100. So here N is equal to 100 and cumulative frequency CF just greater than N by 2. That is 100 by 2 is equal to 50. That is here the cumulative frequency CF is equal to 78. That belonging to the interval 35 to 40. Okay, so therefore the median class is 35 to 40. So here the lower limit of the median class is 35 and class size H is equal to 5 and frequency F of median class is 33. Okay, so and cumulative frequency CF of class preceding the median class is 45. And now if we substitute these values in this formula for median class, okay, so median is equal to L plus N by 2 minus CF divided by F times H. Okay, so now if we substitute these values in this formula, then we'll get this is equal to 35 plus 50 minus 45 divided by 33 times 5. That is equal to 35 plus 25 by 33. That is equal to 35.76. Okay, so median is equal to 35.76. Therefore, median age is 35.76 years. Okay, and now let us move to next problem. So in next problem, here we have the length of 40 leaves of a plant are measured correct to nearest millimeter, and the data obtained is represented in the following table. Okay, so we have given data in this table. So by using this table, we need to find actually median of the median of the length. Okay, so find the median length of the leaves. So here we have some hint. So the data needs to be converted to continuous classes for finding the median. Okay, so here in this table we have given the data which is not continuous. That is why we need to convert it. We need to convert to continuous classes for finding the median. Since the formula assumes continuous classes, the classes then changes to 117.5 to 126.5, 126.5 to 135.5. Okay, and dot 171.5 to 180.5. Okay, so the given data does not have continuous class intervals, so it can be observed that difference between two class intervals is 1. Therefore here here 1 by 2, that is 0.5, has to be added and subtracted to upper class limits and lower class limits respectively. Okay, so continuous class interval with respective cumulative frequencies can be represented as follows. So then the length in millimeter 117.5 to 126.5, and number of leaves Fi is 3 and cumulative frequency is 3. And for this class interval for length, okay, in millimeter 126.5 to 135.5, number of leaves Fi is 5 and cumulative frequency is 3 plus 5, that is equal to 8. Okay, and for this class here the number of leaves 9 and cumulative frequency is 17, that is 8 plus 9, that is 17. Okay, and for this class here the number of leaves is 12 and cumulative frequency is 17 plus 12, that is equal to 29. Okay, and for this class the number of leaves Fi is 5 and cumulative frequency is 29 plus 5, that is 34. Okay, and for this class number of leaves Fi is 4, then cumulative frequency is 34 plus 4, that is 38. Okay, and for this class here the number of leaves Fi is 2 and cumulative frequency is equal to 38 plus 2, that is 40. Okay, so from the table it can be observed that cumulative frequency is just greater than greater than 40 by 2 is equal to 20. Okay, that is actually 29. Okay, so this value belonging to the class interval 144.5 to 153.5. Okay, so the median class is equal to 144.5 to 153.5, and the lower limit of median class is equal to 144.5. Okay, and class size h is equal to 9, and frequency a of median class, this is equal to 12. Okay, so frequency a of median class is equal to 12, and cumulative frequency CF of class preceding the median class, that is 17. Okay, and we know the formula for median, that is median is equal to lower limit L plus n by 2 minus cumulative frequency CF divided by F times H. Okay, so now if we substitute these values in this formula, then we'll get this is equal to 144.5 plus 20 minus 17 by 12 times 9, and this is equal to 144.5 plus 9 by 4, and this is equal to 146.75. Okay, so median is equal to 146.75. Therefore, median length of leaves is 146.75 millimeter. Okay, so now let us discuss question number 5. So in question number 5, here we have the following table gives the distribution of the lifetime of 400 neon lamps. Okay, so here in this column we have lifetime in hours, and in this column here we have number of lamps. Okay, and find the median lifetime of a lamp. So let us solve this problem. So the cumulative frequency with their respective class interval are as follows. So in this class, number of lamps is 14, cumulative frequency is 14. So in this class, number of lamps 56, then cumulative frequency is 56 plus 14, that is 70. And in this class, number of lamps is 60, and then cumulative frequency CF is equal to 70 plus 60, that is 130. Okay, and for this class, number of lamps is 86, and then cumulative frequency is 130 plus 86, that is equal to 216. Okay, and for this class, the number of lamps is 74, then cumulative frequency this is equal to 216 plus 74, that is 290. Okay, and for this class, the cumulative frequency is 352, and for this class, cumulative frequency is 400. So total lamps, that is n, is equal to here 40. Okay, so it can be observed that cumulative frequency just greater than n by 2. Okay, that is 400 by 2 is equal to 200, and here the interval 3000 to 3500, here this is actually just greater than the n by 2. So median class is equal to 3000 to 3500. Okay, so lower limit of median class, this is equal to 3000, and frequency F of median class, this is equal to 86. Okay, frequency of median class is equal to 86. And now cumulative frequency C of class preceding median class, that is 130. Okay, and class size H, this is equal to 500. And now we know the formula of our median. So median is equal to L plus n by 2 minus CF by F times H. Okay, now we know the values of L, N, CF, F and H. Okay, so now if we substitute these values in this formula, then we will get median, this is equal to 3000 plus 200 minus 130 divided by 86 times 500, and this is equal to 3000 plus 70 into 500 divided by 86, and this is equal to 3406.976. Okay, so the median is equal to 3406.976, and approximately this is equal to 3406.98. So therefore the median lifetime of lamps is 3406.98 hours. And now let us discuss question number 6. So in question number 6, here we have 100 surnames were randomly picked up from a local telephone directory, and frequency distribution of the number of letters in the English alphabets in the surnames was obtained as follows. So number of letters in this 1 to 4, their number of surnames is 6. Okay, and in this number of letters 4 to 7, there are number of surnames 30, and number of letters when 7 to 10, there are number of surnames 40, and when the number of letters 10 to 13, there are number of surnames 16, and for number of letters when 13 to 16, there are number of surnames are 4. Okay, and the number of letters when 16 to 19, there are number of surnames is 4. So now determine the median number of letters in the surnames. Okay, and find the mean number of letters in the surnames also. So also find the model size of the surnames. So let us solve this problem. So the cumulative frequencies with their respective class interval are as follows. So for this class intervals, the cumulative frequency is 6, and for this class interval, cumulative frequency is 30 plus 6, that is 36, and for this class intervals, the cumulative frequency is 36 plus 40, that is 76. Okay, and for this class interval, cumulative frequency is 76 plus 16, that is equal to 92, and for this class interval, the cumulative frequency is 92 plus 4, that is 96, and for this class interval, cumulative frequency is 96 plus 4, that is 100. Okay, and now if we add all these frequencies, then you'll get n is equal to 100. Okay, so now it can be observed that the cumulative frequency is just greater than n by 2, and here the value of n is equal to 100. So 100 by 2 is equal to 50. That is actually interval 7 to 10. So the median class is equal to 7 to 10, and lower limit of the median class is equal to 7, and cumulative frequency CF of class preceding the median class is equal to 36. Okay, and frequency F of median class, this is equal to 40, and class size H is equal to 3, and we know the formula for median, that is equal to L plus n by 2 minus CF divided by F times H. And now if we substitute the values of L, N, CF and F and H, then we get median is equal to 7 plus 50 minus 36 by 40 into 33. Okay, into 3, that is equal to 7 plus 14 times 3 by 40, that is equal to 8.05. Okay, so median is equal to 8.05. And now to find the class marks of the given class intervals, the following relation is used. Class mark, this is equal to upper class limit plus lower class limit divided by 2. Okay, so now taking 11.5 as assume mean A, and DI UY and FI UY are calculated according to step division method as follows. Okay, so they are calculated in this table. So here for this class, XI is 2.5, DI is minus 9, UI is minus 3, and FI UI is minus 18. Okay, so you can easily calculate the value for this class. Okay, the values of this for this class, and for this class you can also find the values. Okay, so similar manner you can find all these values, and then if we use the formula, if we use this formula, X bar mean X bar, this is equal to A plus summation FI UY divided by summation FI times H. Okay, so if we substitute the values of summation FI UY and summation FI and H and A, then you will get the mean of the given data. Okay, so now let us move to next problem. So in next problem, here we have the distribution below gives the weights of 30 students of a class. Okay, and find the median weight of the students. So we have given the data in this table. So by using this table, here we can make another table. There will have 3 columns. In first column we have weight in kg. Second column will have frequency, and in third column we will have cumulative frequency. Okay, so the cumulative frequencies with their respective class intervals are as follows. For class intervals 40 to 45, cumulative frequency is 2. For class interval 45 to 50, cumulative frequency is 2 plus 3, that is 5. And for class interval 50 to 55, cumulative frequency is 5 plus 8, that is 13. And for class interval 55 to 60, the cumulative frequency is 13 plus 6, that is 19. Okay, and for class interval 60 to 65, cumulative frequency is 19 plus 6, that is 25. And for class interval 65 to 70, the cumulative frequency is 25 plus 3, that is equal to 28. And for class interval 70 to 75, the cumulative frequency is 28 plus 2, that is 30. Okay, and here total n, that is total frequency is equal to 30 here. Okay, so cumulative frequency is just greater than n by 2, that is 30 by 2, that is equal to 15. Okay, is here 19 and belonging to the class interval 15 to 55 to 60. Okay, so your median class is 55 to 60. And now lower limit of the median class L is equal to 55. Frequency of median class is equal to 6. Cumulative frequency CF of median class is equal to 13. And class size H is equal to 5. And we know this formula, median is equal to L plus n by 2 minus CF by F times H. And now if we substitute the values of L and n, CF and F and H, then we'll get the median. Okay, so median is equal to 55 plus 15 minus 13 by 6 times 5, that is equal to 55 plus 10 by 6, and this is equal to 56.67. Okay, so therefore the median weight is 56.67 kg. And now we will discuss summary. So now we'll summarize whatever covered in this chapter. So in this chapter we have studied the following points. First point is mean of the group data can be found by direct method, that is x bar is equal to summation fi uy, summation fi xi divided by summation fi, and the assume mean method x bar is equal to a plus summation fi di divided by summation fi. And for the step deviation method, x bar is equal to a plus summation fi uy divided by summation fi times h. And with the assumption that the frequency of a class is center as its midpoint, call it class mark. Okay, and then second point, we have studied the mode for group data. So the mode for the group data can be found by using this formula. Mod is equal to L plus f1 minus f0 divided by 2f1 minus f0 minus f2 times h. Okay, where symbols have their usual meanings that we have discussed in our lecture. And third point, we have studied the cumulative frequency of a class is the frequency obtained by adding the frequencies of all the classes preceding the given class. Okay, and fourth point, we have studied the median for group data is formed by using the formula median is equal to L plus n by 2 minus CF divided by F times H, where symbols have their usual meanings. Okay, so in a note to the reader, for calculating mod and median for group data, it should be ensure that the class intervals are continuous before applying the formula. Okay, and same condition also apply for construction of an ogive. Further, in case of ogives, the scale may not be the same on both the axes. Okay, so I stop here this lecture. Thank you very much to all of you.